Okay, we're going to bring up your next speaker now. He's somewhere. Okay. Peter Borah, he's going to talk about a tourist guide to the future.
Hello. So I'm sure you're all as excited as I am to get to Vitalik's keynote, so I'll try to keep this relatively brief. My name is Peter Borah. I currently work for a company called Onage. We're doing video game assets on the Ethereum blockchain. I've been working as a smart contract developer for the past 2.5 years, which in this field is about as long as anyone's had that job title. And I'm really interested in the technology and the future of blockchain. And what I want to talk to you today about is about that future. So I think, hopefully, from the past 2 days, you've come to believe that blockchains are in the future. They're this really exciting new technology that's going to really change our possibilities. All these exciting projects people are working on, all these innovations, all these ideas. But something that might be less obvious from the past 2 days is that blockchains are terrible. So I've been working in the space for the past 2.5 years, and I can tell you this from experience. They're slow, they're expensive, they're low capacity, they're hard to use, they lack privacy. This isn't a contradiction because you are here. This is an Apple II, or possibly here, or maybe here. This is the beginning of a new, exciting technology, but it's definitely the beginning. And you can do cool things with these technologies, right? For a cell phone, you can make calls from anywhere. That's exciting. Apple II, you could do all sorts of new things you couldn't do before. But also, what this means is that the future is going to be very different from the present. We have just begun to scratch the surface of what this technology is going to do for us. And we have some idea of where we're hoping to go with this. But the reality of where we're going to end up is going to be pretty different. And I think anyone who thinks they have a clear picture of what blockchains are going to look like 10 years from now is either very lucky or wrong. But we somehow still have to make decisions. We somehow still have to use this technology, think about the stuff, build projects. So what I'm going to try to do is give you a sense of what technical innovations are coming down the pipe, things I think are interesting, things I think will be relevant, to at least give you a heads up about some of where this is going so that you're able to make good decisions about how you want to position yourselves and your companies. So I'm just going to jump right into some of the technologies that are coming down the pipe that I think will be relevant. The first one I want to talk about is called sharding. So I said earlier that blockchains are slow and expensive. The reason they're expensive and, more importantly, low capacity. So if a real app like the size of Facebook or some major Web 2.0 company, or even a medium-sized app, were to run on a blockchain, the blockchain would break. They can handle a very limited number of transactions, a single-digit number per second, and that's just not going to work for full internet scale. And there's a very simple reason for this, which is that the way blockchains get their good decentralization and security properties is by having every node have a copy of the entire blockchain state. Which is great for security, great for decentralization, but it's a little bit like you had a company with a bunch of workers, and every single one of them was filling out the same piece of paperwork at the same time. And a form comes in that needs to be signed, and every worker in the entire company pulls the form onto their desk and starts filling it out. Obviously, this would not be very efficient, and what it means is that when you add new workers, the work doesn't get done faster, because every single worker has to do all the same work. And this is the fundamental problem with the way blockchains currently work. It makes it really hard for them to scale. So sharding, the basic concept is to not do that. Instead, break things up into groups where each action only needs to be taken by a certain percentage of the nodes, and you can scale it out the way we do every other computer system. This is harder than it sounds because you still want to keep the good decentralization and security properties. But there are people working on this. The Ethereum Foundation has an active project. There are other teams working on similar things. And I expect that we'll see the first versions of sharding, say, in the next 1 to 3 years. And I think the impact of that will be somewhat better capacity. The first versions of sharding will still have bottlenecks. They'll still only be able to scale up to a certain level, but we'll probably get, I don't know, an order of magnitude increase. So this will make things somewhat better. We'll be able to process more transactions, do things cheaper. Challenges are essentially moving past the somewhat better. There are ideas about how you get to like a truly scalable sharded system that don't have some of the same bottlenecks that the current designs do, but they're further out and more research is needed. So that will be one thing that's going to change the landscape in the short-term future. Second one I want to talk about is called payment channels, or you might have also heard them called state channels, which are a kind of more general purpose version of payment channels. So there's a few different projects working on this. In Bitcoin, you have the Lightning Network. In Ethereum, you have Raiden. And there's a few other projects working on state channels, payment channels. State channels, payment channels are they're also trying to solve the problem that blockchains are expensive. They're also trying to solve the problem that blockchains are slow. The Ethereum block time is something like 15 seconds. The Bitcoin block time is like 10 minutes. So that's not going to work for our very fast-paced modern age. So payment channels try to solve this problem. The reason blockchains are slow is basically the same reason. If you have to get every node in the network to process everything, then they all have to communicate with each other, make sure they're on the same page, and there's a limit about how fast that can be. The way payment channels try to solve one particular corner of this problem is by, you can think of it sort of like a check. You have one person who wants to transact with the second person. And in the real world, if you've got money in a bank account and you want to give it to someone else, you don't have to call your bank and both go there and set it up in person. You can hand them a check, and then that person will be able to settle it later with the bank. Payment channels use basically the same idea. You pass signed messages back and forth with your counterparty, and then only when you're done, or if someone's trying to cheat, or if there's some other reason you need to get finality, then you go to the blockchain, present the signed messages, and the transactions happen. I expect to see this very soon, within a year. Raiden on the Ethereum network is supposed to have a working version in just the next couple months. I don't know about the Lightning network. I know they have to get SegWit through first, but should come eventually as well. So this will be very exciting. Impact will be very, very good for a couple specific use cases. So this is good for micropayments. If you have a situation where you're going to be passing small amounts of money around between lots of different people, this is a good use case for that, and it will make it much cheaper and faster. A really good use case is metering. So if you have some resource you want to continually consume and pay for each little bit a bit at a time. So for instance, we heard yesterday about smart cars that interact with a electricity charging station and want to buy a little bit of electricity. The way you probably want to do that to make sure neither side cheats is that every second the car pays a little bit more money and the charging station gives them a little more electricity, and if one of them stops holding up their end of the deal, the other one stops as well. But you couldn't run that on an existing blockchain because that would just be too many transactions. It's too slow, too expensive. But a payment channel is perfect for this because you pass signed messages back and forth, and then only when you're done, once you've actually finished up the charging, then you send it to the blockchain. So it'll be great for that kind of use case. Challenges are essentially expanding functionality. So state channels can work great for certain use cases. There are more than this, for sure. There's other things you can use it for as well. But there are definitely some use cases it doesn't work for, situations where you need kind of more complex behavior, where the order of transactions really matter, don't really work as well in this context. And there are ideas for how to extend it. I've talked to the Raiden team, and they've got interesting ideas. They want to do something where there's more elaborate behavior off-chain, but you can still resolve it on-chain. But it will take more research. So that's the second impactful technology I want you to be aware of. Thirdly, there's a project called TrueBut. Now, this is probably my favorite one of everything I'm going to talk about today. It's a great protocol. It's by two people whose names I'm probably going to mispronounce, Jason Teutsch and Christian Reitweisner. I've even met Christian. I should know his name. But TrueBut is a system that is trying to solve pretty much the same problem, but they're focused on the corner of it about computation. So if you think about all these people filling out the paperwork, when they get to a difficult computation, let's say there's on the paperwork there's some long division that needs to be done, well, they all start doing the long division, and so the computation is also really expensive. So to solve this problem, the way TrueBut works is it has only a small number of nodes actually run the code, perform the computation. They'll upload the result to the blockchain, and then if they try to cheat, if they're trying to lie about the result, then any other node that knows the real answer, so anyone who's also run the computation, can upload a challenge to the blockchain saying, hey, this node is trying to cheat. And the brilliant thing about TrueBut is they found a general purpose way to very efficiently tell who's cheating. They play a little verification game that, in a completely general purpose way, very efficiently figures out who's telling the truth. And it is a great protocol. Those of you who like protocols should go read it. So I think this is great. Time frame, I haven't the slightest idea. They've released a white paper with a pretty complete protocol. It makes a lot of sense to me, but I'm not very sure how far they are on implementation. That said, because there's a white paper out, somebody will implement it eventually. I think the impact will be very cheap computation that is trustworthy and reliable, which opens up a wide range of possibilities once you can have like real computational work done on a blockchain. There are possibilities with machine learning. There are possibilities with all sorts of things that you're currently unable to do will become possible. Challenges, so one challenge is anything non-deterministic. So this works great if you've got like a long-running computation that it's just math. It works less good if there's anything where it's like multiple people interacting and the order in which they interact matters, and maybe different people at different points in the network see the messages come in differently. So that's a limitation. And I think I have a slightly old version of my slides, but so that's one limitation. Another limitation is timing. So because you have to wait for the verification, it will kind of slow things down, which might be OK, but could be a problem for some use cases. Nonetheless, I think this is a pretty exciting innovation, and will change some important things. So moving on. Fourth, distributed storage. So this is trying to solve IPFS, swarm, storage. There's a few different projects doing this. It's trying to solve pretty much the same problem, except this time focused on the storage aspect of it. So every one of these nodes has to store all of the data that's on a blockchain. And this is expensive. This is inefficient. If your like cat picture needs to be stored on every single node on the network, that's not going to scale very well. So again, they try to solve this problem by splitting up the work. Different ones of these protocols are solving different parts of the problem. Some of them are worried more about passing the data around. Some of them are worried more about incentivizing people to store the data. Time frame is anywhere between now and maybe 3 years from now. Some of these protocols already exist. IPFS has a beta version running. That's mostly focused on the transporting and finding data side of things, and there's nothing in there yet to ensure that the data sticks around. But it's all part of the problem and is useful. The impact will be cheap storage that can be done in a decentralized way. And you can even have this interact with smart contracts. This can even interact with the blockchain by using Merkle hashes, which is our particular type of cryptographic proof that let you upload small bits of data and prove. So you upload a hash of the data, but then later to verify some of that data, you don't have to upload the entirety of the data that you hashed. You can upload just a little bit, which can be very efficient, very cheap, and you can still verify that it is in fact a legitimate part of the data that you hashed and put on the chain. So with mechanisms like that, we can interact with this data from smart contracts while still storing it in a much more cheap way. Challenges are guaranteeing availability, like I was saying. There are a few projects that are trying to work on that, incentivizing people to actually store the data. But even those projects will only kind of incentivize people to store it. They won't guarantee it, so it could cause problems if the data is really important or consensus critical. But work is being done, and this will make storage cheaper, more efficient, better. So you'll notice that the first 4 of these that I've talked about are all basically trying to solve some corner of the same problem, which is the scalability issue. And that's because it's kind of the fundamental challenge right now in blockchains, in my opinion. The main thing keeping blockchains from being as useful as they can be is that they're really limited in the amount of capacity they have. And this is pretty fundamental to their design, because the way they get the decentralization and the security is through splitting it across many nodes. And so this is kind of like a fundamental research problem right now. Luckily, I think that there are credible approaches that are working on some aspect of these problems. I think the sort of general idea of having most things be off of the main blockchain and only verifying them on the blockchain in case something goes wrong, I think that's a really powerful approach that we're going to see more and more of over time. 3 of the 4 things I've talked about use that in some way. But it's a hard problem, and it's something you really need to be thinking about over the next 3 to 5 years if you're trying to build blockchain products, because it's going to be a challenge. So keep an eye out for these technologies, because they'll help. So moving on to things that aren't about scaling. Another exciting innovation coming soon is ZK snarks. So ZK snarks are dealing with a privacy issue. Right now on a blockchain, you have to, part of the way they get the good public decentralization security property is because everything is visible to everyone, and so everyone can check the work. And that's great, but it means that you can't do anything private on it. Which is bad for businesses who care about trade secrets. It's bad for individuals who don't want everyone to know exactly how they're spending all their money. So ZK snarks are a form of zero-knowledge proof. What this means is that it's a form of cryptography that let you prove that you've done something correctly without having to show what you've done. So in the context of a blockchain, that lets you do things like have a currency where you can prove that you're allowed to make a transaction without having to show everyone what that transaction is, who it's going to, how much it's for. Which is a really, I'm still sort of boggled that this works. I don't really understand the math, but apparently it does. And this will really make it possible to do truly private things on a blockchain while still keeping the good, decentralized, secure properties. So time frame is about now. The math exists. The papers have been published. There's a currency called Zcash, which uses this in exactly this way. Also on the Ethereum network, which is where I work, my focus, we'll get the basic crypto we need in order to use ZK snarks on Ethereum in the next 2 to 3 months, relatively soon, the next hard fork. So I think the impact of this is that we'll be able to handle things that need privacy. I've mentioned some examples already, but also voting, also medical records, like all the stuff where we worry about privacy, we'll be able to use a blockchain. Challenges, efficiency. So ZK snarks, the reason I put specifically ZK snarks rather than zero-knowledge proofs in general is because they're the first one to really be efficient enough to run on a blockchain. But they're still not as efficient as not using them, and so there will continue to be progress there. And expanded use cases. We kind of know how to do certain things with them, but there will need to be a lot more technology built to handle a wider array of use cases, figure out how all various ZK snark-based protocols can work together, et cetera. Again, since this is slightly old slides, another problem is that right now they require a trusted setup, which means that you have to generate some sort of key that you're going to use to create this whole setup, this whole set of zero-knowledge proofs. And if that key leaks, if someone has access to that key, then they can create fake proofs. So in the blockchain world, they kind of refer to this key as the radioactive waste, because you really don't want it to get out. For Zcash, they did this entire elaborate signing ceremony where they had different people generate different parts of the key, and one of them did it in a moving car, and they built Faraday cages so that people couldn't spy, and physically destroyed the laptops when they were done, just to make sure that this key doesn't leak, because if it does, it pretty much breaks the system. So that's a challenge, and we'll need, ideally, we'd find a way to have a similar sort of system that didn't need that. If we do continue to need that, we'll have to figure out how to manage it. So that's another challenge. But ultimately, this is the first real privacy that keeps the same good properties of a blockchain possible on a blockchain. So that's exciting. Last of the 6 that I want to talk about in detail is CrossChain Communication. So there's a few different projects working on this, Interledger, Cosmos, Polkadot, a few others. Interledger is a very simple protocol for atomic swaps of cryptocurrencies. So if you've got a token on one chain and there's a token on another, you can set up a trade between them in a way that is economically guaranteed to actually work out. And you can trust that if you transferred on the token on one chain, that the appropriate transfer on the other chain will also happen. And it's very general purpose. It will work for any blockchain that can implement some basic smart contract functionality. Cosmos and Polkadot are more elaborate systems that are trying to kind of build a meta blockchain that will have many specific blockchains under them, and that will facilitate more complicated kinds of communication between them. But overall, the general idea is that we've got all these different blockchains, and they're kind of siloed systems right now, and we'd like to be able to have communication between them, get more interoperability. So time frame, not now to 5 years. Something like Interledger is already possible now. The protocol has been published. It's not that hard to implement. So that's available now. More elaborate and systems will probably take some time to get the social buy-in and to actually work out exactly how it's all going to work. But I expect to see it eventually. And the impact will basically be better network effects. Right now, each blockchain is kind of standing on its own, doing its own thing, and you have to kind of pick what ecosystem you want to be a part of. In the future, with good cross-blockchain communication, it's all going to be part of a meta network of blockchains that are going to have better functionality, allow different blockchains to specialize in different strengths. I think that'll be helpful to the ecosystem. Challenging, one of the biggest challenges is just settling on standards. There are a lot of different ways to do this, a lot of different blockchains. So I think there's going to be a major, political, social process to try to figure out how this is all going to work, what protocols are all going to end up using. That'll take some time, but I think eventually it'll happen. So these are kind of my big 6, I think, most important things that are coming down the pipe. But there's a whole bunch more. So one that didn't make my top list, but I'm personally very excited about, is eWASM, which is a project to change the Ethereum virtual machine to use the WebAssembly standard rather than being a custom thing. And what that means, the upshot of that, is that you'll be able to use normal programming languages like C or Rust to write smart contracts rather than having to use the custom ones that we're creating right now. And that is going to make it easier for developers, just kind of more interoperable with the rest of the computing ecosystem. Another big one is consortium chains. All the things I talked about were basically about public blockchains. Consortium chains, there's a lot of innovation going on there. Projects like Hyperledger and the Enterprise Ethereum Alliance are trying to build standards to make it really easy to spin up a private chain. An interesting one is BigChainDB, which rather than starting with a blockchain and trying to take it private, is instead starting with a normal private database and trying to give it some blockchain-like features. Right now, I'm a little bit skeptical of their security model, but it's an interesting idea, and maybe it will grow into something important eventually. And these will be especially, I think I mostly agree with the previous speakers that the private chains are not as interesting as the public ones. But we're about to get cross-chain communication, which means that it doesn't have to be either or. You can have sort of an internet situation where there are private chains that deal with some private use cases, and they can kick things up to the public chain when they need to be more public, more decentralized, more secure. Another one that didn't get a full slide is a formal verification, which is basically a way to prove statements about smart contracts, which is great for security. So you can say, it's guaranteed that this contract will never contain more than a certain number of tokens. There's no possible way that someone could create tokens out of thin air. And then once you can mathematically prove that, you can trust it. And so it's great for security. So a variety of teams are working on things in that direction. The last one is identity and security. We've got these public chains. We need to sort of think about how we want people to interact with them, how to prove that who you are to the blockchain. Right now, we use this public-private key thing, where you have to have some file that you use to sign transactions. And the problem with that is that if your key leaks, you're in a lot of trouble. We don't have much flexibility around that. So projects like Uport are trying to create kind of programmable identities using smart contracts to allow you to do things like taking your account back over if you get hacked and all that sort of thing. And because of blockchains are public and anyone can upload smart contracts, all this stuff is going to be easily interoperable. You can kind of use any security provider you want. So hopefully we'll see some competition here. But people like Uport are working on it. ENS is a project, the Ethereum name service, that is basically like DNS, the domain name system. So rather than having everyone have this crazy long address, you'll be able to have peterborah.eth, and that will be much easier. So yeah, projects like around identity and security also coming soon. So a final note here is that what I've been talking about so far is pretty much just the backbone. It's just the tech. It's like if, going back to our analogy of cell phones and computers, it's like if I got up here and was talking to you about CD-ROMs and transistors and all that sort of thing. It's exciting, it's important, it's part of what's going to change the landscape, but ultimately, even more important is the stuff you guys are going to build on top, the applications, the social things, the legal changes. So this talk I've just given is only focused on the tech side, and arguably the biggest changes are going to come elsewhere. But because it's based on the tech, everyone who's working in the space needs to understand where we're at, what blockchains can and can't do, but also where we're going, what new technologies are coming forward. So that's my talk. You can contact me. My email address, slides are available. Yeah, thank you very much.